That's a pretty nice letter.
And number 1 through 7 odd.
I did all of them for extra credit, Mr. McLaughlin.
Oh.
Dang it.
Number 7.
Number 7. X squared, u of x equals 1 minus x squared. X squared was my domain.
Y, is it y or x? X is not equal to 0.
Domain.
What's my graph? What does it look like?
Auto number.
Auto numbers.
Yes, sir.
What's my domain? What's my range?
0, 1.
What's my graph? What's x squared look like?
Is it the
The
view?
parabola, okay. What's my vertex?
0.
Okay, so what's my range?
All reals except for 0.
Anything greater than 0.
Greater than 0.
Okay. Greater than equal to 0, right? Domain. 1 minus x squared must be what?
It can't be 1.
So again, how do we find domain with radicals? Talked about this?
Greater than or equal to 0.
Alright? What shape is this?
The shape is what? Oh, yeah.
I forgot.
It's a parabola. Parabola's opening is going up or down?
Up.
Not with a negative.
Up or down.
Where's my vertex?
0.
Oops.
No.
Alright, if you can't remember, you gotta graph it on your calculator. Alright, so what's my domain? I'm looking for other values that are greater than or equal to 0.
X is greater than or equal to 1 and -1.
How can it be greater than or equal to both of them? Looking for everything where the graph is above 0.
How do you know it's above?
Because it's greater than or equal to 0.
Okay. So it's greater than or equal to -1?
So I'm looking for, again, location, 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 always deals with my
X?
x's.
Like a real
What
estate.
x's will give me the values that are greater than or equal to 0?
So it's a parentheses?
What values of x will give me values that are greater than or equal to 0?
One. I'm confused. It's
how do you write that?
Parentheses, -1, comma 1.
Why parentheses? Isn't it greater than or equal to?
What?
Isn't it greater than or equal to?
Yeah.
Greater than or equal to 0.
So, parentheses, -1, comma, 0.
But why is it parentheses?
Huh?
Why is it parentheses? There's brackets, is it not?
That's equal to 0.
Correct, so that's why you use the
It's
brackets.
for both? Both sides of brackets?
Where is my graph equal to 0? Is it equal to 0 at 1?
No.
It's not?
Oh. Yes.
Is it not equal to 0 at -1?
No, it is.
Yes, so that's why we use brackets.
You're really overthinking this.
I really am.
Just take a deep breath.
Okay.
You
Okay, so.
sound like a
the
dying door.
bracket-
What's my range?
Wait. Why is it? You don't need parentheses or brackets to explain the domain
No, you do. You just
I
have
do,
to
I
keep
just,
doing
I'm
it.
just using inequalities just for,
for fun, to confuse me?
no,
Okay.
it's the same thing.
Okay.
Don't wait. What's the range?
No, Isaiah.
What kind of function is it?
It is function,
It's a radical function, isn't it?
sure.
What's my range of a radical function? Should, it's one of our basic functions. So I'm gonna help her out. What's my range of a radical function?
Oh, it's hold on. That's spaced out there.
0 to infinity, yes.
Yep.
Radical function looks like this. That's my range. That's my y values. Starts at 0, goes to infinity. So there's my domains and range of each function. If I add them, what do I get?
These you're actually doing dividing. You're not adding for 5 through 6.
Oh, you're dividing, thank you.
Yeah. So it's, first you do f over g, and then you do g over f. So you got x squared over square root of 1 minus x squared.
Alright, so what's my domain?
Well, it's a 1 over f.
-1,
What about it?
the broken part, the parentheses,
Why is it parentheses, not brackets?
because, the domain is just greater than.
Alright, because the denominator can't be equal to 0, correct? G over f of x.
Square
Where's my
root-
function?
Square root of 1 minus x squared over x squared. So x cannot equal 0.
Is that it?
Well, also, there's something else to do with the square root. Hold on, what do you do with square root? Doesn't matter.
Alright, we know this has to be what?
Greater than or equal to 0.
So this one, the radical has to be what?
No, the top is.
But again, we know that the radical,
It's 1
I
minus,
just-
it's 1 minus x
greater
squared
than or equal to?
is greater than or equal to 0.
but what's my domain of this?
Oh, your domain of it.
The,
That.
the -1 is greater than
means everything here, correct? Nothing above, nothing below, correct? Now this is the denominator, that means what?
Greater than 0.
X equals.
Can equal 0. So now what's my domain?
-1 to 0. I don't know how to explain it. The parentheses, -1 comma 0, and then the U, and then the parentheses 0, comma 1 bracket.
Both
No,
brackets.
are both brackets? 'Cause you can't go any farther.
There you go. I had to grow this, okay. I just forgot to write that. My bad.
Alright, here we have to merge both domains together. When you put them together, then you get your final domain.
And the first function, the f of the g, f, all you have to worry about is the bottom, the domain of the denominator. So
Well, the
that's-
domain of this is all the numbers, right?
Yes,
Domain of this is between -1 and 1.
yeah.
But we can't have it included in 1 because it can't equal 0.
Yeah.
Any other questions? We good on those? Alright, pass those forward, please.
Tina.
Alright, today we want to talk about compositions. You guys get your, oh, sorry Shane. Got his ideas, oh.
Why do you always put it here?
I can get both boards.
Why do I have to sit in the 2 front desk of every class of yours?
Think about it.
She said it, not me.
Wait, why? I have the biggest head in here. People need to be able to see over it. Poor baby. Can't even see.
Compositions, hopefully you brought your composition books.
Wait, why am I sitting here? Wait, we need composition books?
Talking about compositions.
I mean, can I go in my locker and get mine?
You're as bad as Kiara yesterday.
Yeah, that's what I was saying.
Huh?
So you're as bad as Kiara yesterday.
Okay. But,
I think it was-
No, you're sitting there because alphabetically, that's where you came, alphabetically.
I'm sure we're all-
Yeah, that one
too.
That Isaiah Gold was written on the ceiling, so.
shut up, Garrett.
Wait, which chapter is this?
We're still on chapter 1.4.
Okay.
1.4. Alright. So compositions. Composition in algebra, we talked about them in algebra 2, F circle G of X, and G circle F of X. You are composing functions, you're putting functions within a function. Another way to write that would be F of G of X, or G of F of X. Now using this is a little bit easier because function notation tells you whatever's inside the parentheses, you put in for the X into the function. And this is what we're doing here. So we start off simple here. We have F of X equals 3X and G of X equals square root of X. Well, we can compose our functions. If you go FG of X, we're going to take the G of X and place it in place of the X and the F of X function. So the square root of X changes out with the X. So FG of X equals 3 square root of X. Took the X out, put the square root of X in. The GF of X, I'm going to take the 3X, take the X out, and put the 3X in, which is the square root of 3X. 1, and g of x equals 3 over x. Alright, so if we're composing, if I have it in this form, f circle g of x, the second one goes into the first one. The second one goes into the first one. The second one goes into the first one. So here, f circle g, I'm going to take the g of x and place it into the x in the first function, which equals the square root of 3 over x plus 1. Alright, if I had g circle f, that means I'm going to take the first one and place into the x of the second one. That's 3 over square root of x plus 1. Dealing with compositions. Another thing. Say we had f circle g of 2. Alright, there's a method of doing this. We're putting the last function into the first function. So what really happens here, if I have a number, I'm going to evaluate the second function first at that number, get an answer, take that answer and put it into the first function. So if I take what this really looks like, this looks like f of g of 2. And that's what it looks like. So if I evaluate g of 2, I get what? Square root of 2. Take that answer and put it in here, which is 3 times the square root of 2 squared plus the square root of 2. Which square root of 2 squared is?
2.
2 times 3 is 6 plus square root of 2, which would be my final answer.
Wait,
Did it the other way around.
How did you get the 2? Where's the 2 from? What?
This 2?
Yeah.
Let's give it to you. Part of the problem.
So
I have a g circle f of 2. That is the same thing as g of f of 2. So it's telling me to put the 2 in place of the f first, get that answer, and put it in for the g function. So if I put 2 in, I get 2 squared.
Oh, you get 12.
12 plus 2,
14.
14. I'm going to take that answer and put it in here. I get
Square root of 14.
square root of 14. And here I got f of x equals x squared plus 1. And I get g of x equals square root of x. I'm going to change one of these. Change it to minus. So f of x equals x squared minus 1. G of x equals square root of x plus 1. Okay? So we're going to do it first without numbers. That's g of x. So what I'm going to do, I'm going to take the where's f of G of X represent? What does that tell me to do?
Put G in for F.
Put G in place of the X in the F. Alright, so that's gonna be square root of X plus 1 squared minus 1, which equals square root of X plus 1 squared is X plus 1 minus 1, which equals X. Go the other way, G f of X, alright, that tells me to do what?
Put F in for F.
Put the F
G.
in for the G. That means the square root of X squared minus 1 plus 1, which that is X squared minus 1 plus 1,
X.
X squared, the square root of X squared is
X.
X.
So it never mind.
Good?
Yeah.
Let's say we had G circle F of 4. That tells me I'm going to do what first? Put 4 for X in the
F.
F function. 4 squared minus 1, 15. And then we'll do what with that? Put in the G, 15 plus 1, 16. Square root of 16 is 4. Right? And the way I did these, it should equal 4. So if I have F circle G of 4, what do you think it's going to equal?
It's obviously going to equal 4 since you told us that.
Right? It's going to equal 4 because that's what it told me it's going to always equal X. Okay? So if I put 4 in for the G, 4 plus 1, 5, square root of 5. And I take that and put it into the F, square root of 5 squared, minus 1, 4. F circle G, G circle F, F of G of X, G F of F of X. So far so good?
Do they always equal the same thing?
So far so good? Yes? Okay, so, domain. Okay? Now if we see what happened here, we put a number into the first function, and then we take the result and put it into the second function. Well, the key here is that my result must match the domain of the second function. The result has to match the domain of the second function. So let's look at an example.
Wait, what'd you say?
The result of the first function must match the domain of the second function.
So the domains have to be equal?
No.
No, they don't have to be equal. But whatever I get for the second, the result of the first function has to fit the domain of the
Oh.
second function. All right, domain of f of x.
No.
All reals. Domain of g of x.
X can't equal 0.
X cannot equal, x cannot equal 1.
Oh, my bad.
X minus 1 cannot equal 0.
Yeah.
All right, so f circle g of x. All right, what am I going to do?
You're gonna take the F and you're gonna plug it. I don't know.
Backwards. Put the g in for the f.
Yep.
Always the second one into the first.
Yeah.
Alright, that's good enough, that's as far as we need to go right now. It's the domain that we wanna make sure,
Can't be equal to 1.
alright? So, this is gonna be all real numbers. So whatever I get out of here must fit here. So anything I put in for x besides 1, is that gonna equal any real number?
Mm-hmm.
Yes. So it fits. So therefore my domain of the whole function now is just gonna be x does not equal 1. Because if I put any number but 1 in here, I'm gonna get a real number. And this one can use any real numbers. Other way around though, g circle f of x. Alright, so if I put g circle f of x in, put it in for the g of x, that's going to be 1 over x squared minus 1 minus 1.
Wait, so are you multiplying to get that? Like when you combine them?
Now I'm going to take this and put it in for the x. That gives me 1 over x squared minus 2.
Can't be equal to 2. I mean, no.
So this is all real numbers,
There's a square there. Never mind.
correct?
Mm-hmm.
Notice that this, the result of this, has to match this. Well, x squared minus 1. What is my range? What do I get when I use all real numbers here?
Anything.
Remember, x squared minus 1 is what graph?
Oh, it's a parabola.
Parabola. So what's my range?
0 to infinity.
0 to infinity. But I can't use 1. So I'm saying x squared minus 1 cannot equal 1.
What does that have to do with anything we just did with the
Well,
g
this,
of
this
x?
is the composition. Now we're gonna find the domain. If I solve this, x squared equals 2x, or does not equal 2, does not equal plus or minus square root of 2.
But that doesn't match.
It does, because down here, x cannot equal plus or minus square root of 2. So what's my domain here? X does not equal square root plus or minus square root of 2.
Instead of like doing that, why can't you just like finding the,
Sometimes yes, sometimes no.
so you have to use the first one for like the.
Mhm. So here, I can use any real number. But my results get me a result of 1, which I can't use. So I gotta figure out which real number I use to get me a 1. And that would be a plus or minus square root of 2, and I can't use that. So therefore my final result is my domain cannot equal plus or minus square root of 2. Let's look at another example. Let me turn that a little bit so. Good. Alright, f of x equals 1 over x minus 1, g of x equals square root of x. What's my domain?
X
X
does not equal 1.
does not equal 1. What's my domain? What's my range? What function is that like?
It's not parabola. It's,
My reciprocal function, right? 1 over x?
yeah.
What's my domain, what's my range on 1 over x?
0, 0,
What does not equal 0? What's my range on the square root of x?
0 to infinity.
Y is greater than or equal to 0. Right? So this is why you need to go back over those functions and make sure you learn what the shapes of those functions are, learn what the domains and ranges of those functions are.
Wait, so it's the opposite of the dome, like the, let's see.
No.
So the range is like,
Range is y's, domain is x's.
we're finding like the possible value of y.
What the y can be, yes. So we're taking f circle g of x. All right, how are we going to find our function?
Of g for f.
Correct? And that's the easy part. What numbers can I use here?
Anything over than 0?
Anything over 0. What kind of numbers do I get? Anything over 0, correct? But when I put it in here, I can't use
0,
1,
1.
correct? So that means this square root of x cannot equal 1. If I solve for x, that tells me that x cannot equal,
Also minus 1,
no,
1,
1. So already I know that I can only use from 0 to infinity. Now when I compose them, I know I cannot use 1. So therefore, what's my domain?
0 to 1, and 1 to infinity.
Is my domain. We go in the other direction. G circle f of x. Gonna do what?
For f and g.
The square root of 1 over x minus 1. What was my domain here?
X minus 1.
Anything but 1. I get what? What do I get? What's my result? If I put anything but 1 in here, what's my result? Anything but 0. Can I use anything but 0 here?
Yes. Well, anything greater than 0.
Anything greater than 0. Okay? So therefore, everything I get here, I cannot use there. So I have to fix my domain. So that means 1 over x minus 1 must be
Greater than 0.
greater than or equal to 0. Alright? Now, if we try to solve this, cross multiply, I get a false statement. So let's think about this. I need 1 over x minus 1 to be greater than or equal to 0. In other words, I need it to be what?
A whole number?
What's that?
A whole number? Positive?
Positive. I need it to be positive. The only thing that will make it negative is this bottom number, correct? So I need x minus 1 to be greater than or equal to 0. Or really, just greater than 0 because it can't be 0. So that means x must be what?
1. Greater than 1.
Greater than 1. Alright? For me to get this to fit this, I need x to be greater than 1. So what's my domain of this? X must be greater than 1.
Wait, so the first function have to match with the second?
The results of the first function must be able to fit the domain of the second function. That's why we need to know both the domain and the ranges.
So in that, like the f have to match with g?
The result of this must fit the domain of this. I get y is not equal to 0. That means positive and negative numbers except 0, right? Can I use positive and negative numbers but 0 here?
Just greater than 0.
I can only use positive. So I get a limit where this only results into numbers that are positive. So I say, okay, what numbers here makes this positive? Well, numbers that are greater than 1 is the only thing. If I have a number that's less than 1, I get a negative number. I can't use a negative number here.
Wait, so all that matters is like the first two functions?
It depends on which direction it goes.
The very first two.
You gotta think about what's happening. Put a number in here first. I get a result. Are my results able to be used here? If not, then I get to adjust it. I get numbers that are not equal to 0. That's positive and negative numbers. Can I use a negative number here? No. So therefore, I got to come back here and adjust to make sure this is only positive numbers. How can this be only positive numbers? X minus 1 must be greater than 0. So when I solve that, x is greater than 1. If I use numbers that are greater than 1, I'm always going to get a positive number, which is always able to be used here, which would always be able to get this. So my domain is x is greater than 1. You just got to think it through. I'm going to stand here and explain all day long. Unless you start thinking it through, you're not going to see it. You got to remember, the results of the first must be able to use for the domain of the second.
What do you mean with the first and the second?
What's one you're going to use first? Which one you're going to use second?
So use first is which one's plugged in which one?
Which one you're going to use first compared to which one you're going to use second? Which one you're going to use first? G or F?
F?
Why would you use Jeff first? That's not what we just talked about all day long. Which one do we use first here, folks?
G.
G. The second one is always used first. F. The first one is always used second. The second one is always used first. The first one is always used second. Let's look at another example. X cubed v of x equals cube root 1 minus x cubed. All right, domain. X cubed, cubic function. What's my domain?
All real.
All reals, yes. What's my range?
All real.
All real, very good. Cube root function. What's my domain?
That's a good question.
All real. Because can I take a cube root of a negative?
No. Yes.
Yes.
Yes, I can. Cube root of negative 8 is
-2.
negative 2. So yes. So I'm going to take the cube roots of negative, positives, and 0. So all real numbers. What's my range? cubing function. Okay? Here's the cube root function. There's the difference. So this one's simple. F circle G of x. F circle G of x. What am I gonna do? Amy, what am I gonna do?
G first, like plug G or F.
Okay, so you already knew that, so you know which one's first and which one's second, correct? Okay? So we're gonna put G here. So it's gonna be cube root.
So it's just gonna be 1 minus x, right?
The cube root of 1 minus,
Cause,
oops, to be cubed,
yeah, so it wouldn't just be 1 minus x.
1 minus x cubed.
X cubed.
What's my domain? What's my domain here? I'm sorry. What's my domain here? What's my result? Can I use all real numbers in this equation?
Yes.
Yes. So therefore there's nothing to adjust.
Yay.
Because my result is equal to something that I can use. Flip it around.
Oh, what?
Alright? So what's my function? Isaiah?
It would be, you plug f into g,
Okay?
so it would be, x, this cube root of 1 minus x cubed cubed,
Which is?
1, could just be x, right? Or x to the 9th. I don't know why I said 1.
Okay, x to the 9th. Alright? So I use this one first, right?
Mm-hmm.
What's my domain?
All real.
What did I get?
All real.
Am I able to use all real in this function here?
Yes.
Yes? So therefore my domain would be
All real.
all real.
So the result is the range.
Result is always the range, yes. Y equals, Y equals. Okay? Got a fairly good idea?
Sure.
It's gonna take some practice. It's gonna take some thought. Alright? Take some practice, take some thought. Use your graphing calculator if you need to. Alright? The graph to see what your range is gonna be. Look at your basic functions to see what your range is gonna be. Alright, they got pictures of the graph there. So that should help. Alright? You are going to try to be doing numbers 11 through 21 odd. 11 through 21 odd. 11 through 21 odd on page 117. 117, 11 through 21 odd.